Okay, Chapter 2, Section 2. This one we are going to call direct variation. Direct variation is when an equation has b equal to 0. B, if you remember in the equation y equals mx plus b, that is the y-intercept. Well, whenever the y-intercept is 0, we call this direct variation. So we have an equation in the form of y equals mx, and if you add plus 0, that means it's direct variation because the y-intercept is 0, or the graph of the equation goes through the point 0, 0. For example, if we look at the two examples that are given here, y equals negative 3x, is that direct variation? Yes, it is, because it goes through the point 0, 0, and it goes down 3 over 1. So we look at this one, and it looks something like this. Okay, what about this one? 3x minus 2, is that direct variation? Well, no, because it has a negative 2, so no, it's not direct variation. The graph of direct variation is always going to go through the origin. Okay, the origin, also known as the point 0, 0, it can be anything, but it is not direct variation unless it goes through the point 0, 0. If a linear function or a straight line is in direct variation, then for any two ordered pairs, x1, y1, and x2, y2, then we can set a proportion. y1 over x1 equals y2 over x2. Basically, this is just the slope. Okay, we know that for any 2 points, the x and y over each other are going to be equal. So if we're given 2 points and we have x, or 7, 5, and x2, I can set up a proportion like this to find the missing x value. So what I'm going to do is I'm going to label them just like we've done before, x1, y1 over x2, y2. And I'm going to put y1, so 5 over 7 equals 2 over x. And if you remember, this would have been in Algebra 1 or even before Algebra 1, how do you solve a proportion like this? You cross multiply. So I have 5x equals 7 times 2. So I have 5 times x equals 7 times 2, which is 14. So I have 5x equals 14 divided by 5, x equals 14/5. All right, let's try another one. If y equals 3 when x equals negative 9, find x when y equals 5. Well, if y equals 3 when x equals negative 9, so I have negative 9, 3, find x when y is 5. All right, so if I think about this, negative 9, 3 is going to look something like this, and blank 5. Well, I know it has to go through the origin in order for it to be direct variation. So if I were to draw that line, I could probably guess where the graph is going to hit, but in order to solve it algebraically, so if we look 1, 2, 3, 4, 5, it's probably going to be between, my line isn't very straight, but probably right around negative 2. Oh no, I'm sorry, y is 5, so 1, 2, 3, 4, 5. Where is it going to hit? Somewhere around negative 11 or 12. I got my x and y mixed up. So x1, y1, x2, y2. So I'm going to put 3 over negative 9 equals 5 over x. Same thing, I'm going to cross multiply 3 times x equals negative 9 times 5, which is negative 45, divide by 3, and x equals negative 15. Which makes sense because if I go to negative 15, it's going to hit at 5 somewhere. If y equals 5/17 when x equals 10, find y when x is 5. So I have my 2 points. I'm going to set up my proportion again. So I have 10 and 5/17 and 5y. So this time we're not given the y, but we can still set up our proportion. So what I'm going to do is I'm going to label it x1, y1, x2, y2. I'm given 5/17 over 10 equals y over 5. Now do your cross multiplication. 5/17 times 5, 10 times y. This gives me 25/17. 25/17, because I multiplied the tops and multiplied the bottoms, equals 10y. Now, we could divide by 10 on both sides to get rid of the 10 to get y by itself. But the problem with doing that is then I leave myself with a fraction over a fraction. So instead of dividing by 10, I'm going to multiply by 1/10. 1/10 of 10 is just 1, so I'm left with y. And here, now I can multiply the tops and multiply the bottoms. We get 25 over 170. Okay? If you're not sure, use a calculator. Direct variation is an equation with b equals 0, always. So it looks like this, y equals mx, where m is your slope still, but my y-intercept is always 0. However, with direct variation, in math, we're going to rename the slope k. That way we can tell the difference between the slope, whether it's direct variation or whether it's not. So in this case, it is direct variation, so we're going to call it k, also known as the constant of variation. And you need to know that because a lot of times on Math Excel or on test or whatever, it's going to ask you find the k value or the constant of variation. You need to know that just means it's the slope of direct variation where the y-intercept is 0. So if y equals kx, where k is the slope, what is k? Well, if you remember in the first 9 weeks, we were able to solve. We got out a highlighter and we solved for k when there were multiple variables. Well, in this case, we're going to do that so that we know what k is. K is just y over x. I'm going to divide both sides by x, which gets k by itself, and I know that k equals y over x, and that is true for direct variation anytime. So if you're given 1 point in direct variation, you automatically know the slope, or you know the constant of variation. So determine whether y varies directly with x, and if so, find the constant of variation and write the function rule. There's a lot of information in those directions, and you're going to be asked to do this again. So we know that k equals y over x. We just determined that, okay? And this is y, and this is x. Since that's the case, I'm going to, for each and every point, I'm going to put y over x. So I have negative 2 over 1, which is negative 2. For this one, negative 8 over 3, which is just stays negative 8 over 3. And for this one, I have 14 over 5. Now, is this a sample of direct variation? If I were to plot these points, would they all have the same slope? No, this one's negative 2, this one's negative 8/3, and this one's 14/5. So no, this is not direct variation. Okay, it says determine whether y varies directly with x. In this case, no, it does not. So we can move on to the next question. Now, determine whether y varies directly with x, and if so, find the constant of variation and write the function rule. So for this one, y over x, don't forget k equals y over x. So 6 over 9, which reduces, divide by 3 on the top and bottom, which gives me 2/3. This one, I have 8/12, y over x, which divide by 4 on the top and bottom gives me 2/3. This one, I have 10 over 15. Divide the top and bottom by 5, which gives me 2/3. Now, what do you notice about all of these k values? They're all the same. So what we can say is that, yes, this is a sample of direct variation. Okay, if we were to graph the points 9, 6, 12, 8, and 15, 10, we would get a line that goes through the origin and that has direct variation. So in that case, yes, it is. So it asks, if so, find the constant of variation. Well, if you remember, the constant of variation is k. Well, k is y over x, which is all of these. So for this problem, k equals 2/3. All right? Then write the function rule. Well, the function rule for direct variation, if you look back on the slides before, is just y equals kx, but we're going to replace the k with 2/3. So the function rule is going to be y equals 2/3 x. And you are going to have to do this again, so make sure that you understand this. We're going to do another example. Okay, determine the direct variation equation through the point 6 over 5. Okay, so this one's a little different, but we're still given a point. Okay, these are all just points. This one just doesn't ask me to determine if it's direct variation. It just says give me the k and then write the function rule. Well, remember this is x and this is y. Therefore, in order to find k, I have to take y over x. So k is going to be 5 over 6. Since that's my k value, now I have to write the function rule or the equation, which is just y equals kx, which is y equals 5, 6x. You have to, on Math Excel, it's going to ask you for either the constant of variation, also known as the k, or it's going to ask you for the equation or the function rule. This is the k, okay? K is y over x. Okay, the function rule is y equals kx. Okay, that is the most common mistake that students make when they do direct variation. Okay, so make sure you understand the difference between the constant of variation and the function rule or the equation. Find the direct variation equation through the point -7/15, and then this one, the directions, I want you to graph it. So this is x and this is y, so that means k equals 15 over -7. To write the function rule, I have y equals 15 over -7x. How do you graph that? Well, remember, this k is also known as the slope, okay? Or we're also given a point. So we can either graph using the slope or we can just graph the point. Now the problem is, on my graph here, I'm not given 15, it goes out till 10. So I'm going to make each line equal 2. So I'm going to start at 0, 0 because it is direct variation. Always start at 0, 0, and then I'm going to use -7/15 or go down 15 over 7. So -7, 1, 2, 3, 4, 5, 6. Oh no, each line's worth 2. So 2, 4, 6, 7. So we're right on the inside. Then we go 2, 4, 6, 8, 10, 12, 14. And then 15 is going to be right in the middle. Okay, and then I'm going to connect those dots. And that is my direct variation equation. Okay. Let's keep moving. All right, finally, when a bike is being pedaled in a certain gear, it travels 10 meters for every 4 pedal revolutions. So if you think about it, for every 4 times you go around, it's going to go 10 meters. So how many revolutions would be needed to travel 500 meters? Well, this is an example of direct variation in real life, okay? If you think about direct variation, this one's however many pedal revolutions to how far you travel, but if you think about it, gas mileage in your car is also direct variation. If you have 0 gallons of gas, you're going to drive 0 miles. If you have 1 gallon of gas, depending on your car, you might go 20 miles, or you might go 10 if you have one of those big trucks, okay? So for this one, how do we solve it? I'm going to pick out my 2 points. For every 4 pedal revolutions, okay, I'm going to go 10 meters. So 4 pedal revolutions goes 10 meters. So how many revolutions will take me 500 meters? Just make sure they line up. 4 stands for the revolution, so 10 stands for the meters. Therefore, X stands for the revolutions, 500 stands for the meters, and then we can set up a proportion. X1, Y1, X2, Y2. So I have 10 over 4 equals 500 over X, and then cross multiply. So I have 10X equals 500 times 4, which is going to give me 2,000. And then to solve for X, I'm going to divide by 10. Take away a 0, so that gives me 200, excuse me. So 200 what? Well, how many revolutions? 200 revolutions.